Welcome to Stone Oyster's final project prototype video. The Stone Oyster solution involves collecting waste oyster shells, then crushing and mixing them with a polymeric resin to create sustainable countertops. Prototypes were to be made to undergo material properties testing to ensure a product met or exceeded those properties of our competition, quartz and granite, for example. The initial prototype plan was segmented into two halves: product development and testing. Product development involved the collection, crushing, sorting, and sieving of the oyster shells to ensure an appropriate particle size distribution for our MVPs and material testing samples. Based on availability of sieve sizes, we were able to sort and separate shells with particle sizes ranging from 20 millimeters to sub-micron sizes. Product development was completed in late January of 2020, and 40 kilograms of shells were crushed in total. The next step of the prototype plan was the testing and validation section. This section comprised of making ASTM standardized samples for a suite of materials tests described later. Samples would undergo 4 different tests, and based on the data, the sample's composition of percentage weight resin and particle size distribution would be iterated until the iterated sample would pass all test conditions. Due to supply chain issues, we could not secure the polymeric resin needed to create the ASTM samples, so true MVPs were created using an epoxy-based resin. The testing and validation process was the only step we were unable to complete as UBC's labs are closed due to the COVID-19 pandemic. This video demonstrates the stages of the crushing process, where full shells are dumped into a series of crushers, starting with the crusher yielding the largest particle size, followed by the one yielding the second largest particle size, and so on. Our initial MVP, made in January of 2020, seen on the left, consisted of roughly 30% resin by weight and was made with the smallest particle size available, less than 3.35 millimeters, and had a density of roughly 2.1 grams per cubic centimeter. This MVP was made quickly to showcase our technology at a business competition, where we received valuable feedback from customers demanding larger particle size in the sample. From this feedback, we created our second MVP in February, as seen on the right, with a much larger particle size distribution range. This second MVP consisted of, again, roughly 30% resin by weight and particle size distribution ranging from 1 micrometer to 20 millimeters, with a final density of roughly 2.3 grams per cubic centimeter. This was the last MVP we were able to make due to the closure of UBC campus. In summary, these MVPs proved the technology of Stone Oyster and allowed potential customers to imagine a full-scale countertop. The test suite mentioned earlier was created to ensure the following features were present in our product. 5 out of 6 of these features are mandatory and are expected for a countertop. These features would be validated by the following tests: scratch resistance, HMV2 microhardness test as per Silva et al., temperature resistance, heat withstanding test, food safe ASTM C97 absorption test, chemical resistance ASTM C650 home detergent test, fracture resistance ASTM C880 flexural strength test. The following flowchart demonstrates the test suite needed to verify and validate the features mentioned. Failure criteria is described by either ASTM standards or customer feedback. The uptake of our product is key to our business success. Therefore, customer feedback is also a huge part of our validation process. Multiple samples with the same particle distribution range and percentage resin by weight would be tested simultaneously and individually for a single test, and composition would be iterated until all samples of a single composition passed the entire test suite. We anticipated the most challenging tests to pass would be flexural strength and scratch resistance, and that these two tests would take up the majority of the iterated process. For Stone Oyster to further validate its technology and have any chance of scaling, this test suite must be completed in the future, as this is the stage gate hindering the completion of a full-scale countertop. We thank you for watching our prototype video.